Well, hi, and thanks for joining me here in my shop. Just before I get going, just a little bit of an explanation of how I got to here. The last video I posted was a fairly short video about the magic eye, but in fact, the things you saw me do in that video were taking place amongst another effort simultaneously, where I was investigating the hum level on this radio. So I don't know if I'm going to go back and grab any of the video that I did while I was doing the initial hum investigation. So for now, what I'm going to say is that this guy hums like crazy. It's absolutely intolerable hum when I have the receiver, amplifier, and its proper speaker connected together. So I must resolve this hum, and I have to do it quickly because my time is running out with this radio. It's leaving in a couple of days, like it or not. So I'm really feeling the pressure at this point. So I did a lot of preliminary poking around, and I can tell you, looking at this schematic, just reminding you that this is the amplifier, this part sitting here, and all the rest of this is the receiver. I've narrowed the hum down to not being in the front end of the radio at all, but being out here, starting somewhere after the detector. Maybe it's the 45s that are really the source of the hum and the circuitry around them. I'm not sure. The amplifier itself, when I run the amplifier without an input, its hum level is very, very low. In fact, it's comfortably low. As soon as you plug in the receiver, it's a whopper of a hum. Now, all the time I've been working on this radio and making videos, and you've been listening, you've been hearing the output of the radio way back up in here, up in this area. We have not been listening down here at all. This is the first time I've really, or second time I guess, I hooked it all together. And this is the first time since I altered the power supply and removed the input capacitor to bring down the power supply voltage, which worked beautifully at bringing down the power supply voltage. But I believe at this point that eliminating the one capacitor down here has introduced a hum problem. If we look just a little closer here at this schematic, and we look at the rectifier tube, and the output of the rectifier tube is heading into this filter choke right here, and then there's another filter choke right after it. All the stuff back this way is quiet, humless, hum-free. If you look, there's a line that travels from here and goes into the center tap of the output transformer of the 245s. So I'm quite suspicious there's hum in this line and hum through all this. And it's come because I've removed this capacitor, which is right ahead of this filter. Right? So what I'm going to do first is I'm going to continue to try to focus in on where the hum is coming from, because I can't be absolutely sure. It's just a theory I'm giving here. So I think the first thing I will do, excuse me, this is the second audio amplifier. This is quite a radio. As an initial audio amplifier, a second audio amplifier, then into the 245s, and then all the way over to the two A1s over here in the amplifier over here. I mean, that's a lot. That's a lot of stuff. So I'm going to investigate right around here. I'm going to find out, just thinking about how to do this, probably going to use the oscilloscope so we can see the signals. And we'll just poke around in here and see where the hum's coming from, if it is there. I believe I have to have this whole thing connected up. And that's the last thing I'm thinking about before I start the actual work, is do I need to plug all this stuff together and turn it all on? If you have to listen to this screaming hum, it's a heck of a hum while I'm working on it. So I'm going to think about that a little bit more. Hopefully not. Here we go. Okay, I've been tossing around various options here on how to proceed. There's quite a few different ways to proceed, including pulling tubes out and seeing what that does and other stuff. And I'm also still unsure about operating the receiver without the amplifier operating fully too. And what I'm really getting at is this hum situation maybe only occurs when everything is hooked up and running. I hope not, because I really don't want to listen to it. It is really loud. So, and that suggests something fairly dramatic has happened here that produced that kind of hum, or a tiny hum early on in the amplifier stages. So the tiny hum is getting amplified, which I really think is what is happening. So if we look, and things get very complicated here in terms of testing, because once you get past this tube, it's all input-output transformers from there. Push-pull input-output transformers. So I'm going to listen to the output of this tube. This is the 6C5. This is the kind of the last preamp stage, I guess you could say, just before the signal is split and shot off to push-pull amplifiers. So we're going to listen to it. Actually, we're not going to listen to it. We're going to watch it or see it on the scope. I know exactly where this connection is right here. I know where this transformer is, and I know where that capacitor is, and I even know where this resistor is. Wow! Let's take a look at it. So the transformer is here. The red wire is actually the input to that transformer. It comes off these capacitors. This is just two in parallel to make up one capacitor here. 0.2. This is a fairly large 0.2. And this is the plate terminal of the 6C5 tube right here. So we hook up the scope here. We can see what's there. Now I still have the audio being sent over to the video system you're listening to. It's coming on this wire. That's actually ahead of the points I'm testing. So I don't have it. I have the volumes down so you can't hear anything, except what might come across on the microphone, and there's no speaker hooked up, so you shouldn't hear really anything. I'm just clearing my head here before I power this up. First time today. And did I say it? My plan is to drum the hum out of this thing come you-know-what or high water. And high water is possible because there's a huge amount of rain coming all through Ontario yesterday and today. A very large amount. Kind of wrecking Halloween here. So let's see if I can cheer up my Halloween with a hum-free radio. Okay, so I don't think there's any reason to hesitate to power it up. Let's do that. Okay, and the scope. So let me get everything set up here. I don't have the camera set up properly yet. Okay, so we're going to start out listening to the radio, as I showed you, right at the volume control earlier in the radio. That's what this white wire is doing. It's conveying the audio out of the radio and into my sound system so you can hear it on the video. Here it is. I challenge anybody to hear a hum in this. Turn the volume down on the radio. So no one could complain about that in terms of hum. There's like zero hum at this stage. Now here's what happens here in my shop, and this is what has been kind of throwing me off. This is my scope lead and ground. I'm going to apply the ground. The volume is still up a little bit. So you're listening to the radio. I'm going to apply the ground to my scope. So there's some of the first challenges that I have. Is this the hum I'm going to see? Now this is not the hum I was hearing, because I made sure during one of the earlier tests that you haven't seen on video, with everything operating, nothing was hooked up to anything. Just all operating in isolation. I even plugged it from my isolation transformer. I plugged it into a regular outlet just to double check, and the hum did not change. The powerful hum. So what am I supposed to do here now with this situation? That's a really good question. And why would it even start humming? Is there a second ground on here that you know what? Yes, there is. There's this. There's this. That could cause a hum loop. I also have the antenna hooked up. Let me take the antenna wire off here. course, if I take this off, you'll stop hearing the hum because the audio won't be connected anymore. The simplest stuff, eh? Well, let's carry on with the experiment here, and we'll see what happens. Okay, so I've got everything connected up here. So when I switch this guy on now, the receiver is going to come on, the amplifier is going to come on. The speaker located behind me has its own microphone. Let's just give that a quick test here. Hello. Okay, that's the microphone in front of the speaker. But chances are we'll hear the hum just fine with any microphone in here because the hum was, I don't want to say thunderous, but you will maybe hear it. Volume down. Radio's on AM. There's no antenna connected because I have nothing connected to this radio now except the radio itself. No equipment, no grounds, no nothing. Okay, let's go. Of course, I'm starting it with the dim bulbs, and they've come on quite bright, of course, because they have a lot of load on them now. They have the addition of the amplifier here. I'm just going to give it a moment to kind of come up. Let's go. Here we go. Anybody hear a hum yet? Here it comes. So that hum, I'm sure you heard it. You must have heard that. That hum is intolerably loud. Okay, so here I am now in this position. I have all this equipment hooked up. We are hearing the hum, but we won't hear it earlier in the radio. That verifies the hum is real. It also eliminates this weird ground thing, which, or putting a ground on causing the hum. Putting a power line neutral connection onto the... So what to try now? So I've discovered I have trouble hooking up my equipment to this radio to make tests like this. I was going to use the isolated voltmeter technique. So what I'm going to do is I'm going to disable the amplifier again because I just don't want it going. I can just simply pull this plug out. There we go. So I won't have to hear that. Just assume that. How is this power cord dealt with? What did he do over here? So that's a two-pronger, of course, and the power comes in. Like you see, I just installed a fuse. And then the power goes straight into the primary of this transformer. It doesn't go anywhere else. So everything going on in here is after the transformer. None of this is any kind of surprise or news. Just verifying what I believe to be the case. Voltmeter, this isn't going to help. I'm going to read some small voltage, AC voltage, and what am I going to know from that? That that's the hum we're hearing? Let me try something more dramatic. Let me pull out the let me pull out this tube. These. Oh, that's not the right. Oh, that's right. It's a 6J5 instead of a 6C5. Right. Let's put that there. So what I've done now is I've interrupted the audio signal at the last audio preamp just before the 45s. I don't think that's going to make any difference, but let's find out. Here we go. Well, we're not going to hear it with this not plugged in. Jim. Let's just plug this back in here. Better be listening to the real McCoy at this point, so as not to be thrown asunder. Okay, so that's on dim bulb supply. Oh, I can hear it already, I think. Or was that a big truck outside? Let's go full power. Okay, everybody's warming up. Silence. Wow, okay, that was, I think we may have found something here. Super silence. Super duper silence. Now, the amplifier down here is running wide open, so anything gets to it, it's happy to amplify it 100% or full blast anyway. It heard nothing. Okay, I'm going to ponder this. I'm going to take a look at the schematic and think about what is happening with that tube out. Oh, that was much better than I expected. Okay, let's track back just a little further. We'll go back to the detector output. That's where the audio starts. After the rectification of the detector, the signal is sent right into the detector tube again to go through the triode. So we'll hear what's coming out of the triode side of the detector tube, which we won't hear it. We will see it on the scope, which should be able to get it. 1, 2, 3, 3. I should see something right here. Okay, so I have to wait a while for the. Oh, it's on DC. Here, let me put the AC. There's a little hum there. Okay, let's track back just a little further. We'll go back to the detector output. That's where the audio starts. After the rectification of the detector, the signal is sent right into the detector tube again to go through the triode. So we'll hear what's coming out of the triode side of the detector tube, which we won't hear it. We will see it on the scope, which should be able to get it. 1, 2, 3, 3. I should see something right here. Okay, so I have to wait a while for the. Oh, it's on DC. Here, let me put the AC. There's a little hum there. So again, we're kind of stuck with the question: is that hum, being introduced by the test equipment, and that's all I'm doing, or is this hum really existent? I think if I shut the power off, that might clue us in. Let me make this a little. That's just a beautiful, beautiful sine wave there. It's fantastic. Let's kill the power. Well, it went away completely. Turn it back on. It looks like it's being modified by the circuits as they warm up there. There's a little glimpse I got of it. That's pretty convincing that it's actually the radio and not the test equipment arrangement. The actual voltage is quite low here, 50 millivolts per, so it's 100 millivolts, so 0.1 volt. Well, 0.1 volt on the grid of a tube like this, or this is supposedly coming out of the detector triode. That's a lot. Humming in the detector. So what's on the grid of the detector triode? Because I'm on the plate of it right now. So when I go back to the grid, we're just getting into more and more sensitive stuff. That's pin 5. So we'll look at pin 5. 1, 2, 3, 4, 5. This is so 5. Well, that's the actual detector plates. I guess that's the only place to go. detector plates. Yeah, really. There's nowhere else to really go. Well, okay, let's go on the detector plates. What happened there? It's kind of... What's that all about? What I'm asking about is why is it jumping up and down like that? Why would that do that? Take the ground off. What's going on there? I'm going to hook up the audio here. As I do it, we can watch and see if some kind of this introduces a hum or something. Okay, so this is the ground. Okay, so we hear it, and I see something did show up on the scope. This is what we're listening to. We're listening to. It's pretty noisy, just like this. Okay, now I want to hook this up again to the audio. It's got to be past this point. It is past this point. So I hook it up to the usual spot. Now I have this ground on, there's no hum. So that says something about my sound system being isolated. I guess maybe it is. So we'll put this on. I'm clipping it basically onto the volume control. Okay, let's see what we can hear. So there's no antenna on the radio right now. Let me just touch the antenna terminal here. Oh boy, I don't think I want to do that one. Headphones on. Oh, I have to do it with the headphones on. I think of these headphones as like electrodes on my head, you know. Touch something. Yeah, that's my finger tapping the antenna. So the radio's just very, very quiet with no antenna. I don't hear any hum. Now, I do hear a little bit of hum. We'll put this on. Ground will cause a hum. It makes this whole thing kind of a joke, doesn't it? Back onto the here. What I find humorous, it doesn't take a lot. So something funny is going on there. As I flex that connection, there's some things going in and out somewhere. I don't even think it's that connection. Something is happening up in this radio here. Oh yeah, I'm going to take these big honking metal pliers here. We could hear it, couldn't we? We could hear it. So if I can make it happen with these. good. Oh! Oh! What did I just do now? So what just happened? As far as I know, I grabbed a little piece of wire there and hardly moved it. Let's stop with the big honking metal things here. So I don't know if this is, am I chasing the hum thing now? Or am I off on another wild goose chase? Okay, hand on the chassis. Oh, jumper. What the heck was that? And now here's a little more hum now. A little more hum. Tell you what, let's take a really close look at this. Let's take a close look at it. See what we can see. Okay, so what we're looking at is the socket of the detector tube. And right in the center there, these two terminals are the two diode plates. You can see they're hooked up to one wire which has been passed across both of them and then tack soldered on. This is the last guy's work there. And that last connection, that's not looking so good there. Maybe I just have to resolder these. And they hook up to a wire. And why is that popping like that? Oh, that's the input. It's just the input clip lead to the audio system we're still listening to. So that's a wire. That's a wire coming from. If we just follow that green thing down the hole there, that's the new or the replaced IF transformer. And some of these wires might be just like somewhere else on the radio, and they might be shorting out in here. So when I'm yanking on this hard, I'm wiggling this wire a little bit. Again, that's just a coincidental pop there. That's nothing, doesn't mean anything. In fact, there, we won't hear it anymore. So is there a problem right there where the wires go in? Doesn't look like it. Looks perfectly good. That's how it looks. So I could move these wires a bit. And we could see the result. I don't see anything that looks like a short against the chassis there. Could put an ohmmeter on this and wiggle it and watch what happens. Just solder it. And so what would happen if this connection were to come off, like if it's not working? Well, then we go down to one plate. This is not a full wave rectification going on here. It's just using two plates in parallel. Give a little more current, I guess. I guess. Lots of frayed wire there. Sometimes frayed wire can be a problem. No. Could also be cold or bad solder joints that I managed to strain when I was pulling on that. Anywhere in this area. Look at that one. It's not looking so good. Okay, so I'm going to resolder that. That's definitely not very good. But that's on this tube. And this other one doesn't look so hot either when I'm looking at it. No, that's solid. But this one, the lead wire coming up from the terminal doesn't look like it actually took any solder. It's probably just fine. But let's see if we can go from probably to certainly here. Okay, so here's a thought. All the way along we've been listening to this radio while I've been working on it, and no real hum in it, and we've been listening right after the detector. So actually that proves audio can come out of that detector clean of hum. So now we're somewhere between the detector and the 6J5. Somewhere in here. Yeah, just right in here. Okay, study up the schematic some more and come up with a new theory. You know, I might as well do something here and just gather more information, and sooner or later something is going to point directly at what we're after. So the name of the game here is Okay, so after thinking about this a little more, I think I'm going to go back to the idea that pull this tube out, the hum disappears from the speaker. Put the hearing in the headphones, it's pretty low. It's just got a little speaker in it. I don't know what's going to happen here. Okay, so now all you're hearing are microphones and speakers. So the hum you're hearing now is coming from this guy. So first, can we hear the hum right here? Yeah, we can hear it. Okay, here we go. Where's the hum the strongest? Oh. What's going on there? Wow. Oh. Hwah! What am I touching? That has got just a pile of hum right here. A pile of it. There's a pile of hum in the radio. I found the pile. What did I actually find? So I have to study the schematic on that guy. Maybe there's an error in there. Oh, that'd be great. If I can find my error, I'd be happy. Let me study up first. Okay, well, just, you know, a bit of an act of desperation. I pulled the two expander tubes out, the expander amplifier and the expander tube. They're out. We're still listening to the output of the 6C5. Let's see what happens here. Will it hum? I'm going to turn off the microphones and we'll just listen to the radio now. that's kind of interesting in itself. Both expander tubes out, and it's humming like crazy. There's the hum. Well, it certainly verifies that I can hear the hum at this point. I'm pretty sure of that now. And that's good for my testing to continue. Continue with what? I'll have to think about the implications of pulling those tubes out and the hum remaining. I don't think it was as loud. Okay, let's try the signal tracer again. Here. So again, what I've basically done is I've just traced the hum that's starting way up here. Let's just go through this again because I got such a whopper hum from this one pin. Let's hear it again. Let's keep poking here. Let me wiggle the whole tube. Easier said than done. Oh, the whole socket here is wiggling. Come on, camera. It's as loose as can be. It's not as loose as can be, it's loose. So these sockets, there we go, perfect. These sockets have extra terminals mounted on them. There's one here and one up in here. This one up here doesn't look like it's, there is something on it. Wow, that's sensitive. Finger on the chassis again. It was sensitive. Pointing back to this terminal or something on this socket. Something I can't see. Oh. I'm moving a wire here. I think just wiggling the, just keep wiggling the socket one way or another. Well, really can't nail down any particular termination. this hum, you know, some of these sockets, the socket itself can have trouble. Watch your hand, man. Resolder all the connections on that. That's what I'm going to do. Okay, so I've resoldered all the connections up there, but in the midst of doing all this, I've discovered that one of the microphones I'm using all the time is noisy. Listen. I'm going to leave that one off. We'll just go with my bench microphones here, which will be fine. So I think we're ready to give this guy another try. My gosh, everything's beeping everywhere. Here we go. So we're hooked up here. That's the volume up a little bit. I can't imagine this is going to help out, but let's see what happens. There's definitely a little bit of wonky soldering up in there. A little bit by me and a little bit by the last guy. Oh, I can hear the deep hum now. Well, I think I found the sensitive spot here. Oh my gosh, what are you going to do about that? So I don't know exactly what's happening yet. I just pried up on that socket a little bit and whop, out she came, humming like crazy. Oh boy, oh boy, oh boy. What do you do about that? Pin resistance to the chassis. Oh my gosh, what do you do about that? You stop and think for a bit and calm yourself down here. I don't like where this is ending up. I don't like it at all. Okay, so I took a little break for lunch, but before that I did do the test I planned to do on the socket. I hooked up my ohm meter 1 by 1 to each terminal, and then I worked the socket with the stick, and nothing whatsoever happened. Excuse me. Every pin appeared to be rock solid. Whatever resistance it read, it just continued reading while I pried away. So that didn't really lead anywhere, but just in observing it, just in looking at it just now, maybe I can see what happened. Let me just find my camera here. Let's take a closer look. Okay, let's take a look here. So this is the socket in question here, and right up in the back here. So let me start here where it's a little easier to see. You see that riveted terminal right on the corner? That is not grounded. That is just a free terminal, free for connections to be made to it. And they are. So we'll just go around each of these terminals here. We'll start with those two are the diode plates. This is a little tricky what's going on here. solid though. It's quite solid. Yeah, that's quite solid. Okay, next pin is this supplementary terminal. Okay. So this is where we need to pay really close attention. It's right up in the back there. From the rivet in the corner. And that's the rivet holding the, yeah, is it? Is that a hold down rivet? So I think this is a ground terminal here. This thing is a grounded rivet. And then normally what they do in these radios is they don't rely on the rivet. They will attempt to solder it. Looks like they bent over the pin terminal down onto this grounding terminal, and then what is that up in behind it there? That's a rivet. Oh no, wait a minute. So I'm flexing the tube from the top of the radio now, watching all this stuff move. Whoa. Yeah, here's another one of these rivets. It's really in the clear. You can really see it on this other tube base. Riveted terminal, which I don't think is grounded necessarily. So if it's just a terminal, the rivet doesn't play any electrical role. It's just holding it in place. So it wouldn't really matter as long as you solder things to the top of it. But this one's a little different. This one has been bent over. Come on. It's really awkward to get a camera in here. Well, that's not a rivet down there. That looks like a bent piece of wire is what it looks like. Okay, so when I pried up on the socket and got the huge hum, I've been pushing this side downwards towards the chassis, and I wonder if that's contacting the chassis right in there, and that's the whole problem, is leaky stuff. The way this is done, this looks like it should be tied to the chassis. Okay, let's poke around with a meter here and just see what there is to see. Okay, so the first thing we want to check is it grounded? Okay, let's get my meter there. Good. Okay, so the pin we're after is right up in here. This guy is definitely grounded. Now, let me hold it there and flex the trying to get out of the way of the meter here, but okay, I think, oh, crying out loud. Come on. Oh, we're crying there. Whoa, whoa, oh, I saw it. I almost knocked, hey, everything's falling over. I almost knocked my camera over. I saw it jump there. How about I just push on it here? No? Okay. Oh, crying out loud. Can you see that? I'm really getting frustrated, aren't I? It's a bad thing to continue this work while you're frustrated. Bad thing to do. So I'm going to stop as soon as I finish this. Take a good long break because I'm getting thoroughly upset. Okay, so we're touching that contact. Now I can poke away and see what happens here. I thought I saw something. Oh no. It's probably just a bump. Oh! It's probably just a bump. Well, I don't want to break the I think that's solidly grounded there just fine. Okay, that didn't go anywhere. Should I turn this guy back on and we'll hear the hum again. Okay, power back on. Now this is going to sound different. Just make sure the volume is down a little bit on that. Watch this. Now the hum's going to come a-screaming. Yeah, here it comes. Hey, there's a big lesson right there. There's a big lesson right there. Okay, let's just, what did we learn? We learned something. Okay, so I decided I'm going to try it again with its amplifier and speaker all operating together just to see where we're at for a bit of a reality check here. So we still have the green wire disconnected. You can actually see it in the camera there. But that should have, well, that'll have zero effect. Right now, let's take this off. No grounds on here anywhere, but the antenna is connected. Down. Here we go. Power. Some funny sounds come out of it. Mechanical sounds, heating up sounds. Okay, I'm going to leave it on restricted power here for a while. So I'm not sure how loud a hum we're going to get here. Oh, that was interesting. This thing worked without a hum for a second. This guy worked for a second. Well, that's not the blasting hum. It's definitely still too high. Maybe I've done something that's changed things a little bit. The hum is still definitely too high. Now we're only on restricted power. So if I put this on full power, it'll be hummed right out of here. How is it worked briefly with no hum? Did I imagine that? Well, it's not very dramatic here, but watch when I'm going to flex the socket by reaching around and flexing the tube up and down. We're measuring the resistance to the chassis using clip leads on my meter. Okay. Shouldn't really wiggle this one. So this is the wonky connection here. Well, now I'm gonna wiggle. I'm telling you, I found the problem. That's what I think I'm saying. It should be 0 to ground, 0 to the chassis. Now I'm gonna wiggle. It's just barely touching it. Look at that. So whether that is the problem, I don't know. It's a problem. It's a simple problem to fix just by soldering it to the chassis. Almost certainly it was supposed to be soldered to the solder spot up there. Soldered to the chassis, that thing will be grounded solid, and we'll see what happens. Using a clip lead for temporary testing, and that's not going to work because it looks like just an ohm or two, and you're finished. And why would it hum like a son of a gun? Because if you lose the ground connection there, then the cathode is tied directly to the heater and to the heater line. Doesn't sound like a good idea to me. That's probably where the whopper hum came from. And then with the little bit of resistance in there, some amount of hum coming. Okay, I will attend to that. Okay, I managed to get a piece of wire soldered in there now, so that terminal, that riveted terminal, is now soldered to the chassis, I'm sure it was in the factory, and I'm sure that was a, well, I guess we can call it a mistake that was made by somebody working previously. You just can't depend on rivets. It's just not going to work for you. You know, in a factory setting, if they depended on rivets for grounding, then almost every one of these would come off the line with it. The problem in it, a really difficult problem to find too. So, okay, so here's what my meter is able to do. It's going to go right to 0. Well, that's where it's stopping, 0.1. So I'm just going to pick a grounded point. Here's a grounded point way down here, and the terminal right here. And what happened on the meter? 0.2. Zero. Well, it's not going to go lower than 0. There we are. So that terminal is now solidly grounded to the chassis. Let's give it a go here. So we're still hooked up to the speakers, the amplifier. The amplifier is plugged in power-wise. This clip lead here for no good reason. Hopefully that wasn't humming. The audio that goes into my video system is disconnected, so all we can hear is the speaker, the real speaker, through the microphone. In case, I'm going to put on my own headphones here. Okay, I'm going to check the other microphone. Okay, that's all good. So there's a big moment here. This could be a big moment. So, odds. So I give the odds of this fixing the hum problem in this radio 10%. Chance that it's fixed it. That's how I feel about it. Okay. Just a wee bit of volume there. I also give it a 10% chance that was a bad thing to do. Maybe a 1% chance. Here we go. Okay. Good on the dim lights. So I can hear a deep hum in here, but it's not very loud at all. Hey. There's no hum. I'm frozen. I'm just standing still because I can't believe it. Well. Wow. Okay, so before I go crazy here, we better put this on full power. I'm sure it's going to hum more. Very, very, very deep hum. Okay, full power. Wow, I'd say the hum went away. Coming around.
Might be the most criticized coach in the league. I am sure they will not do this, but is there ever...
That's the sound of the radio with the volume turned down. Silence. Okay, let's just go a little closer here. Maybe down. How about keep an eye on the eye? Yes, an eye on the eye. Okay, a little volume up.
Election strikes the final blow. He said, we used to see a light at the end of the tunnel, but that light turned out to be an oncoming train driven by Justin Trudeau. Sonia Savage is the energy minister of Alberta. And first of all, Minister Savage, you used to be here in Ottawa with me. Yeah, hi. Great to have you on the program.
So join me, Andy McNamara, every Sunday at 8 a.m. for the Fantasy Show, delivered by Domino's Pizza on Sportsnet 590 The Fan.
I can just kick back and do nothing all day. New speakers in my home, new speakers in my car. Visions Electronics. Home and car installation and automation is easy breezy. Mounted flat screens to speakers. Music and binge-worthy TV shows at the touch of a button. Car decks to car starters. Now, if only the Visions Electronics technicians could bring me a cold one. No? All right, I'll just get it myself.
Tone control.
Visions Electronics. The better price, the wider choice, the smarter advice.
From the excitement of their first day to walking proudly across the graduation stage, school's the start of a
That's
journey
an excellent
that can
tone
take
control.
kids anywhere. Our education education system needs to evolve to reflect this journey, to better prepare kids for the future and the jobs of the future.
Sounds
so
good right there to me.
Updates with a focus on positive mental health, technology, skilled trades, and math. So our kids
let's
are prepared
just give
to
a shot on
succeed
shortwave.
every step of the way.
Why not?
Learn how the government is improving your child.
Okay, shortwave. Now let's get this right. So I think that's long wave. No, we're not doing that. That's AM broadcast. This is the short wave. We should go. Well, let's try it out. Whoa! Whoa! Okay, let's try the other band. The other band, the last band, the highest band. This is the more likely one to pick stuff up. We're at the bottom of that band. We're at the top. We're way at the top. 18 megahertz. Nothing up there. We want to be down around 15 at least. Around in here. Some kind of interference. That's it. Okay. 14, 13, 12, 11, 10. So we're really down in this area is where
ajeno al hospital, pues a veces trataremos de reforzar dentro de las cocinas gracias de seguimiento
it's fading.
Los trabajadores de la funeraria municipal de Madrid anuncian movilizaciones ante la intención del ayuntamiento de privatizar este servicio. Elena Nieva.
UGT y comisiones obreras anuncian movilizaciones y el alcalde Martínez Almeida insiste en privatizar la funeraria municipal. Los sindicatos le piden que aclare sus intenciones y denuncian la falta de transparencia de la empresa. Alberto Soria, UGT, Manuel Carmona, comisiones.
Seguir esta situación se volverá a encontrar con la presión frontal de todos los trabajadores y de todos los madrileños, que son los verdaderos propietarios de la empresa y los principales perjudicados.
Es un despotismo y un nepotismo que estamos viendo día a día. En mi día estamos viendo desde que se ha dejado tiempo a todo el mundo, tiene tiempo a reconstrucción antes de que ya es un cortijo.
Los trabajadores están preocupados también por la reducción.
Se está realizando.
Same station. Well, okay. Looks like I still got another challenge because I didn't see the eye operate on the high shortwave band at all. And it's pretty clear to me, listening to that station as it faded in and out, it got a lot louder and quieter than it should. The radio should be compensating for that quite a bit. So, but the good news is, the horrible hum is gone. Oh man, what a journey this radio's been. Thanks so much for watching. Goodness knows what I've edited together from hours of hum hunting video. I have hours now to find that. To find that rivet took me hours. Okay. Thanks again for watching. We'll see you as I try to figure out this problem now. deadline looming.